All right, Hannah.
Sex girls.
Hannah asked me to go through FRQ number 7, so I figured I would just go ahead and do that for this today's video.
Go, Hannah, go.
My husband is obnoxious. What is wrong with you? Be quiet. Anyways, clearly he's not getting enough attention. A random sample of 29 employees have their systolic blood pressure checked. Summary stats are below. So everything over here and this stuff is our summary stats. Again, I'm always thinking forward to what we might have to do. We got a quantitative measure, so if we're doing anything later, it's going to be in means land. We only have one sample, so it would be a t-test, a t-interval, that sort of realm if we end up there. Then we keep reading. It says, assume the value for all people is normally distributed with a mean of 122 and a standard deviation of 20. So this is the real deal values. And then it says approximately what % of adults will be greater than 142 millimeters mercury. So we're looking for a percent. We know we're dealing with a normal distribution. We're talking about all adults. So we're doing all the stuff in the blue. We're not dealing with the sample data yet. So we're 122, and we want to know about greater than 142. So this section. Now, it does say approximately, so this is one that we could be a little bit more clever about, but I'm guessing for most of you ladies, what you would do on this problem is normal CDF, lower is equal to that 142, labeling everything so we get all of our beautiful points, upper is equal to E99, and then our mean of 122 and our standard deviation of 20. What this is, though, is exactly one standard deviation above average. So if we were thinking about what this looks like, right, we're in that 68%, that area right here, because we're within one standard deviation. And then we need, that means how much is left. My brain cannot process. 32% is left on the outsides, which means we have 16%. So this is approximately 16%. If you did normal CDF, though, you're getting out a more accurate value. But it does say approximately, so it is okay to use the empirical rule or the 68, 95, 99.7 rule in this case. All right, so, and again, normal for these normal questions with probabilities, typically there's those pieces they want in that rubric that we have labeled our parameters. We have given the bound and the direction, which we also have here, and then we have the correct value. So we've got all the pieces that we would need for the rubric for any of these normal probability questions. B says, describe the distribution of systolic blood pressures for the 29 employees that were sampled. Okay, so describing a distribution, we know we want to deal with SOCs, right? So we need our context, we need shape, outlier, center, spread, all that stuff. We have center and spread really easily because we have all the measures, but we don't have a drawing, right? So if we have all of the summary stats, the easiest drawing we could do is to do a quick and dirty box plot, right? A box plot lets us look at the men, and we're going from 110 to 175. So 1, 11, 12, 13, 14, 15, 16, 17. So something like that. So 110 is my men, 124 is my Q1, 140, 12, 13, 14. I should have labeled these. I'm being bad. And then 15 and a half, and then 17.5. So looks choop, choop, choop like that. So we can't see anything about modes. We could say this looks roughly symmetric with no outliers.
Agua.
So we got the first two pieces of SOCs done. Centered at a median of, I'm going to go ahead and use median mode just because we use that to make this cute box plot, 140, and has an IQR of whatever 156 minus that is 21.5. And here's one thing we need to make sure we have some reference. So we might want to put at the beginning, systolic blood pressure is roughly symmetric, or just throw in some units here on those two measures of center and spread. Either one of those will get us our context and knock the rest of this out in terms of SOCs. All right, so C, the company CEO wants to know if the mean systolic blood pressure of employees at the company is higher than the national average. State the hypotheses for this test. So nice thing here is that, like I said, I don't expect them to make us do the mechanics. I do expect them to have us actually state the hypotheses. So in this case, we want to know if it's higher than the national average, and that is a known value. We actually have a given value. And remember, back from the beginning, we said we only had one sample. So this has got to be a one sample t-test. We got to be dealing with a HO of mu is equal to some value. In this case, the 122 for the whole nation. And ha, we do have a keyword of higher than, so mu is greater than 122. And if I want to be cute about it, I could put mercury, and I might put mu is equal to, or not might put, I need to put mu is equal to the mean systolic blood pressure for employees at this company. Because remember, it is kind of important. Mu in this case is not talking about the nation, it's talking about the employees at this company and the real systolic blood pressure for them. All right, let's see. D says the conditions in C are satisfied. The hypothesis test gave us a T and a P. This is what I said I thought will happen on the test as well. We're going to see them just give us out the output instead of us having to do that. Interpret the p-value. And then what would the conclusion be? This is exactly what we saw in that 2007 test. This is a beefy part D. It has two huge pieces. First is that interpretation of our p-value in context. Given the mean systolic blood pressure for employees is, and we could either say 122 or the same as the national average. The p-value gives us the probability. Value is the probability of observing a sample as or more extreme than the one we did. So we could just stop with observing a sample as or more extreme, or we could say observing a sample mean of 139.8 or higher, right? So as or more extreme, I can either put in the number or not. We saw last time in the 2007 exam that they didn't actually require you to bring up the sample mean in that. So that's just this piece, interpreting the p-value in context. Then you have to say what the conclusion is. I'm running out of space, but since we have a very, very small p-value, and we need to make sure we say this, right? There's the pieces we need to say. Since the p-val is less than any reasonable alpha, and we can use 5%, we get to reject the null. So there's our first piece. Second, that means that there is enough evidence to say that the systolic blood pressure for employees at this company is higher than the national average. The mean systolic blood pressure for employees at this company is higher than the national average. Right? That whole thing. Boop. And we practice the crap out of that, so hopefully we feel good with this. Part D, I'm hoping we see something like this because it brings me joy. We're hoping now to see what a type 2 error would be for this particular one. So remember, type 2 means that this was the truth. We failed to reject, so we decided this. So in a type 2 error, we would decide there isn't enough evidence, right, to say that the average was higher at this particular company, when in fact it actually is. So that's what they'd be looking for. Context about failing to reject the null, and then the truth is it actually is higher, but we did not make that conclusion. Oh, all right. Things just got crazy. So a lot of people have been interpreting that this is going to happen and that we're going to see a bivariate situation probably within another problem. So all of a sudden we're now switching gears and we're looking at systolic blood pressure and ages. So we're doing a nice little regression analysis. They've given us our scatter plot, our residual plot, and then that table of values. And looks like we have two things to do. I just want to make sure. F is interpret the slope. G is comment on the strength, direction, and form. Basically the Duffs, or whatever we called it, from our scatter plot. So interpreting the slope, remember when we have this regression line stuff, all we want out of this is two coefficients. This is going to give me, it looks like we're using systolic blood pressure as our y hat. So systolic blood pressure, make sure you put a hat on it. That was one thing that Professor Rossman was very adamant about, that they didn't give students full credit if they didn't put a hat or just write predicted systolic blood pressure for the end of that. And this is equal to 97.0771 plus 0.9493 times age. Better than using X and Y is to use the actual variable names. That way you don't have to define them separately. But yes, so this is always just the coefficients. Whatever is next to your X variable is your slope. It's going to go next to the X variable in the line. Whatever's next to constant or intercept is just your Y intercept. So in this case, when we go to interpret our slope, we're only going to interpret that. And that was the for every one increase. And this is straight off that sweet sheet that we have. I should put units. So every 1 year increase in age, systolic blood pressure is predicted to increase, I'll be right there, sweetheart, by 0.949 millimeters mercury. Perfect. Remember, one thing that is important is that you make sure you have that word predicted in there. Otherwise, you will do at best a P here. Now, the last one says, part G says, comment on the strength, direction, and form. So that's when we're looking here. There is a strong linear, positive relationship between, and make sure you get your context, between age and systolic blood pressure. It does say explain, so I would go a little bit further. This is actually part of what they did on that Wolf question forever ago that I had to grade. Strong, because and you could say moderately strong if you want to couch this a little bit. They're not super close, so moderately strong is probably better, because the points fall close to the trend line. Linear, because the straight line does a good job. Something like that, modeling the relationship. And positive, because as age increases, systolic blood pressure increases. Something like that. So I haven't looked at the key to this one. It's obviously not a standard College Board one, so it doesn't have a rubric the way a College Board one normally would. But glancing through this answers, let's see what they have. Cool. They have the two things. You could use that, like I said, 15.87 or 16%, whichever you did. Shape, roughly symmetric. Good. They did not draw that from the box plot. They looked at the mean and median, which is completely legitimate as well. In this case, you can see the mean is 139.8. The median is 140. Very, very close. Center, you could say the mean or median around 140. Again, standard deviation or IQR, either one for spread. And then outliers, they went and checked the actual rules to see if there were outliers. Again, I think it's completely fine to just do a drawing quick of your box plot. C, make sure you define mu, the true mean systolic blood pressure. It's either equal to 122 or greater than. We've got our p-value breakdown, assuming the mean systolic blood pressure is 122. The probability of obtaining a sample of 29 with that or more is that probability. Great. This is essentially impossible, and therefore we have convincing evidence to reject the null and claim the mean systolic is greater than that. Beautiful. Everything we saw. Type 2 is what we saw as well before, deciding not to reject the null and claiming it actually is not over it when it is over that. And then we can see interpreting the slope. Same thing that we just did. And ooh, I like that. They actually went a little bit further. I didn't even consider this in our part G. They looked at the R squared and used that to start talking about whether or not it was squared. That, to convert that to an R. That's very clever. I, on the other hand, just looked at the actual thing. But yes, they went down and broke down what those reasons were for each of those pieces as well, which I do think they would make you do as part of the justification. Like I said, I think they're going to go a little bit further than just say what it is. It's going to be, how did you know that, or explain what that means.